Now, the geographic inquiry process, I would submit, means that data acquisition is iterative. And I hope these previous 9 steps that I've outlined are helpful. But as you go through mining for data, you're again going to be going through this process where you're asking a geographic question, you're acquiring the resources, the data that we've been talking about, you're exploring it, you're assessing it, you're analyzing it, you're acting on that knowledge, you're sharing that knowledge with others. And this often leads, it should lead to additional questions along the way, leading to additional data inquiries. This is an iterative process. Let's pick apart how this actually works in practice. Not in huge amount of detail. I've got some words on these slides, and I encourage you to skim these. But let's use a real world example. I recently received a request from an educator who needed to support a project involving drought in Colorado with these data sets that you see here: moisture, stream flow, precipitation, temperature, agricultural health. What kind of data is available? So I followed my own advice and went through those stages that I outlined for you a moment ago. And my result of my investigation are as follows. I found the Geospatial Centroid at Colorado State University, the Open Colorado Data Catalog, Colorado View, and also portals from different agencies such as the Department of Natural Resources. Now, they required close evaluation to determine if they met the inquirer's needs, but also there was an example of a DNR viewer from the Department of Natural Resources, which does not allow for the downloading of certain kinds of data sets, but another portal from the same agency does. So you need to do some investigation here and some deep dives. On streamflow, for example, from the USGS, one of my favorite resources is this waterdata.usgs.gov. But again, thinking about a new paradigm, it's also a live data feed in ArcGIS Online. And so the advantage there is that you've got it instantly at your fingertips, no processing required, and it's a data feed. On the topic of groundwater, I've found this report and sets of data, reservoirs, Living Atlas of the World as well, but the level of the reservoirs is a bit more difficult to obtain. And this indicates another tip that I have for you all, and that is sometimes the 20th century methods actually result in low-hanging fruit to be plucked, and if you know what I mean. It may involve calling or emailing the agencies themselves. Oftentimes, almost always, people are more than willing to share data. If it's public domain data, and if it's not even on their site, you're an inquirer, email or phone, they'll provide the data for you. Agricultural health, I found some mixed results there. An agricultural stress index from the Food and Agricultural Organization. State Department of Agricultures are good sources. There's also a story map with some links to individual map data layers. So sometimes story maps actually provide some links that are useful, even if it's not a portal like an ArcGIS hub. Continuing our investigation now, on the topic of temperature, I recently worked with an ESRI colleague on the data team, and good news. My colleague created this average global air temperature layer. Very nice. On the topic of precipitation, in conjunction with an educational project, I compiled this layer as well as other Colorado layers, and I display them here in this gallery. The precipitation data came from CocoRa's, one of my favorite data portals. It's been around for 20 plus years. And in terms of water use, this remains challenging, but there's a Living Atlas collection that contains water-related items. And there's also this water use report from the USGS. This might be a good use for LocateXT, where you've got location data inside a document like a PDF. I hope that summary was helpful. Let's talk about something else that's related. How can you know if data is any good? The data quality behind it. There's 2 tenets that I'd like to bring up here. Fitness for use and truth in labeling. Fitness for use means it is the data user's responsibility to determine whether a data set is fit for their project. Truth in labeling means it is the data producer's responsibility to provide metadata and other information that describes the data accurately. This enables the data user to determine fitness for use. Now remember though, folks, with modern GIS capabilities and ease of publishing data in many different ways, every data user is now a potential data producer. Thus, everyone in GIS needs to pay attention to both fitness for use and truth in labeling. Here are some data quality examples that relate to this question about how can you know if the data is any good. Let's take a look at these images here, for example. Let's take a look at this essay of mine about why data quality still matters now more than ever with some key examples here. Intentional offsets on web maps. Let's take a look at that. And why does it matter? Here's an example from Lyme disease mapping that a colleague and I did some years back that I think is still incredibly relevant today. Faked satellite imagery? Let's take a look at that for a moment. And finally, here are some tips of mine about teaching about spatial data quality. What really matters here, folks? Be critical of the data. All data. Be critical of it. Recognize its incredible utility, its usefulness in a wide variety of settings and projects. But also recognize that it's limited. Maps are representations of reality. We can't map the world at one-to-one scale. That would be a big web map or GIS data layer, wouldn't it? If we could map it in paper, that would be a huge piece of paper to fold. But the point is, maps are representations of reality, very useful representations, but representations nonetheless. There's generalization, there's map projection issues, there's all kinds of things with our oblate spheroid, right? And getting that into a 2D or a 3D map or GIS database. So be critical of the data, including and perhaps especially mapped data. I think mapped data has this air of authenticity. It's often just believed because it's a map and it looks authoritative. But be critical of it. Remember, anybody can create a map from a GIS nowadays and serve it for millions of people to look at. Be critical of it. Take a look at a couple of these examples. 3,000 degrees in Texas. I know it gets hot in Texas, but this was from a data feed that was online for at least a year before it was taken down and corrected. And also the precipitation rate and humidity and the wind speed are off the scale. The only thing that's normal here is the pressure. But if you weren't critical of it, your interpolated surface of a variety of variables, weather related, would have a big spike at Cleburne, Texas, if you weren't critical of the data. This lower right image was in a catalog, and to the fairness of the publisher, they eventually, after I and a couple of colleagues wrote to them and said, map orientation, the image really does matter here, the way it's oriented. Please fix. And they did. What about this? George Mason University. I thought it was a major research institution. Simple Chinese fast food chain. Why does it say that for the subtitle? Interesting. Also, I know many of these maps are generated for people to click on websites, and some of them are kind of fun, admittedly, but be critical of those as well, even ones that are meant to be funny. What is the end value for some of these things? For example, favorite foods in every state. Oh, you're from Pennsylvania? What's your favorite food? I'll put it on the map. Your office mate is the end value of one. So be critical of those maps as well. For more bad maps, see my presentation here. All data are created in a societal context. A lot more we could say about that. Here are some selected societal issues therefore surrounding data. Location privacy. Should I share my own location? If I want that pizza to be delivered, absolutely. I don't want to just say, well, I'm somewhere in Colorado. I'm going to give my address. Should I share the phenomenon that I am studying? Should I share the location of the people I am studying? What are the implications of doing so? Think about that when you're sharing. Copyright, another huge topic right there. Am I allowed to use the map or image content in my GIS project or my story map for that matter, or a dashboard or other means of communication? Where can I obtain permission to do so if I encounter copyrighted material? What sources can I regularly access that are not copyrighted? My own and also from certain federal agencies in the US, for example. Ethics. Another huge topic. How can GIS be used to benefit society and not harm society? What are everyday critical and ethical decisions that I need to make and that you need to make and that we need to make in using GIS? Let's pick apart ethics a bit more. Ethics matter in GIS because, touching on what I said a moment ago, geospatial data are powerful and oft used means of communicating, right? Maps have been used for thousands of years to communicate, of influencing also and making decisions. Data is not created in a vacuum, but rather in a value-laden societal framework. And a couple implications are, first of all, maps are powerful means of communication. So take the responsibility as map author. Everyone is a map author nowadays, seriously. Again, maps have this sort of aura of authenticity. They tend to be believed just because they're a map, especially with all these wonderful cartographic tools. They can look really good. Be thoughtful about the projection, the symbology, the classification methods, and other techniques that you're employing. Do not intentionally mislead your audience. Mark Monmonier's book, How to Lie with Maps, is essential reading here. Due to crowdsourcing and WebGIS, remember, everyone is now a potential map producer, no longer just a map consumer. With a greater number of maps, this means there's a greater variety of maps and purposes than ever before. Again, be thoughtful about the maps and data layers you select for your own purposes. Here's the cartographer's code of ethics. I'm not going to read all these. You can read them, skim them for yourself, but straightforward, know your audience, do not intentionally lie with the data, choose your symbols, your projection, your classification methods wisely. The map should be repeatable, and then also pay attention to different cultural values and principles. This is from a Cartography Thematic Map Design book by Dent, Torgerson, and Hodler. There are some deeper dives that we'll go into here for just a few moments. The Cartographer's Code of Ethics I've already mentioned, but the GIS Certification Institute, the people that grant a GISP, also have a code of ethics that I think is very well done and worth looking at. There's also my guidelines, ways to teach about ethics. And there's also some wonderful case studies in ethics from Penn State that I highly encourage you to look at. They're very compelling. They're short and sweet, but very thought-provoking. Here are a few recommendations about teaching about and with data in terms of what we've been talking about. Not too many, just something for you to think about. First, include lessons where students must go to a wide variety of data portals at a variety of different scales and themes. Then they have to practice accessing the data from those portals and dealing with all of the inherent challenges. In other words, don't just package up everything into these nice, tidy lessons and give the students these data sets that are already ready to go and they're all packaged and clean. Make them deal with these uncertainties of some of these data portals and the decisions that they have to make in whether to use or not use some of the data layers on those portals. Include discussions about societal issues surrounding data throughout each course, rather than just kind of saving it for, well, today we're going to talk about societal issues. Weave those discussions in throughout. Include at least a few lessons that are structured such that students face a problem and have to determine, well, where am I going to get the data to solve this problem? So they have to, again, access and process that data and use the data in a problem-solving environment with GIS tools. As I mentioned at the beginning, this data topic can be a bit dry, okay, admittedly, but keep it interesting. These are incredibly relevant topics here for our times. The data discussions can be dry, admittedly, but if you use this gigapixel image, for example, to teach about location privacy, wow, are there any faces that are grayed out or pixelized or pixelated? How many people in a sample of 10 are on their smartphones, and what are the implications there? Include at least one lessons where students have to populate their own metadata. We've got some lessons and some guidelines and some documentation as to how to do that. Include at least one lesson where students are faced with a map or data layer that looks valid and appealing, but it contains very little or no metadata. And then discuss, should the data layer be used? If so, in what context? But I recommend you let the students bring up, hey, there's no metadata, rather than you as the instructor pointing this out. Let them point this out and then deal with it. Well, folks, to sum up, this is an important topic and I hope you agree. Let's talk about how do you continue your learning in this important area. First of all, the Geospatial Data book, blog, and 10 lessons that actually use public domain data and problem-solving scenarios is right here on spatialreserves.wordpress.com site. It originally came from a Esri Press book that a colleague, Jill Clark, and I wrote, And we continue the discussion with the blog. Second, put data to practical use via lessons in the Learn Lesson library. Do a search on data and some other topics, and you'll be able to dig into this in a practical way. Back on that Spatial Reserves data blog, for high interest, search on everyday examples. That has the IoT feed with the 3200 degree temperature reading in Texas, the George Mason University as a Chinese fast food chain, and also a Beatles album that's not really an album, it's someone's misspelled playlist. But again, it's the whole theme of that particular essay is being critical of the data. And there are other fun but insightful examples, including fish at a food store. Point is, be critical of the data, including and perhaps especially mapped data. And finally, explore the ArcGIS Living Atlas of the World and revisit it often, as remember, it's living and continually updated. I hope this discussion about data has been relevant, interesting, insightful, and I encourage you to teach about data, use data, be critical of data, and it's an exciting world. It really is. There's no shortage of data, but I think because of the volume, there are some concerns that we need to cultivate as we teach and do research and work with colleagues and students and others. Thanks for being with me.